All right, so this morning I'm going to be talking about plant growth regulators in wheat. And I am from the University of Kentucky, and we don't use plant growth regulators a whole lot in Kentucky, but there is a lot of interest recently in them. And so I'm going to talk about some research trials that I've done and some out of Michigan as well. And so plant growth regulators aren't necessarily a new thing, right? They've been around for a long time. So back in the 90s, we were even using plant growth regulators in Kentucky with Cerone. Does anybody remember Cerone?
Oh, yeah.
Yeah. How well did that work for you guys here?
Well.
Did it work well? It was really hit or miss in Kentucky from what I understand from my predecessors. And so, I pulled up the Cerone, the label, when I was preparing for this meeting, and it was interesting. There were a lot of warnings, right? So if you start going through the label, they're saying, okay, so the application timing for Cerone is later than some of the newer PGRs in wheat, peaks 8 to 10, okay? So that's past the reproductive joining stage. It also tells you that you need to be careful that you don't let this contact the head, okay? So that's warning number one. You need to make sure that the temperatures are at least 60 degrees for it to be effective. If you have any sort of stress that's occurring at application timing, you might also decrease yield. And these are all on the label. Do not use in non-lodging situation. It may result in yield loss. Not only that, but it may delay harvest. It may delay, so do not use on late seeded crops in short seasons, growing seasons, due to a delay in possible maturity. And so for Cerone, there were a lot of caveats. And I know that it was not used very often in Kentucky, mostly because it was very inconsistent and cultivar dependent. And so in Kentucky, we don't necessarily need PGRs except for in extreme cases, okay? We don't have a whole lot of guys putting manures or litters down on their wheat ground. And so we typically don't have excessive growth. But we do have some lodging, and this is from one of my trials, from time to time. And even in 2013, we had excessive lodging throughout the state, which was a result of a drought the year before that. So we had a lot of nitrogen carryover. And so really in Kentucky, for a long time, we didn't worry about plant growth regulators, and the producers didn't use them, and it wasn't really on their radar. And then what happened, in 2012, 2013, they released Palisade, right? And so this was a totally different active ingredient than Cerone. And so our producers became very interested in it because the literature from the company and even from some universities and preliminary trials were saying that it would increase yield. And so for our producers, they were always looking for a way to increase their wheat yield, aren't we all? And so the increased yield, reduced plant height, and then Syngenta also said that in their trials they found increased stem thickness and diameter, which helped reduce lodging. Michigan State had it was more like an extension publication that I found back in 2013-14 that said that it increased yield about 12 bushels. And mainly that was a function of reduced lodging. And so really what I wanted to understand and what my producers wanted to understand was, hey, can we put out 200 units of nitrogen and get higher yields and use Palisade to help reduce any potential lodging? And so really that's what my studies, I had 2 years, 3 site years. That's what I focused on, okay, was can we really push the envelope on nitrogen applications, and will Palisade reduce any lodging? And so I went in with the plant breeder. So I had a site year in Lexington, and then I had 2 site years in Princeton. This is where I'm housed in the far western part of the state. And so he looked at these trials. He helped me plant them, but I harvested them and did all of the management. And so we went into conventionally tilled soil, which is a little bit of an anomaly in Kentucky. Usually everything I do is no-till, but the breeder has a conventional drill, so we had to drill it into tilled soil. What we wanted to do was we wanted to look at 3 varieties. I mean, we couldn't let this thing get too out of bounds in terms of cultivars, but even Syngenta said that Palisade, a response to Palisade is cultivar dependent. Okay, so we did know that going into this project, but we had to make choices as to what our treatments were going to be. And for us, we chose 3 varieties. I'm not sure if these varieties are probably not familiar to you guys, but 25R32 was a little bit of an early maturing variety in our environment. Pembroke is more of a mid-season, and Truman is extremely late. Extremely late. It will mature very late in the season. Not only that, but it's a pretty tall variety. But it's high yielding. And we haven't grown it in many years like production, but we use it a lot for controls and studies because we have a lot of data on it. And then I worked with the soil specialist, and he suggested going for 5 nitrogen rates in 50-pound increments. And so that's what we did. And you can see here, this is early in the spring, after we have all of our nitrogen down. You can see the range in nitrogen rates, right? You can definitely pick out the zeros, but you can also pretty well pick out the 200s. And so as an agronomist, you know, those 200 units, they were really pretty, right? Dark green, lush, lots of growth. But we were also worried about any sort of susceptibility to diseases as well, which actually didn't occur, and I'm not sure how. We dodged a bullet there. But they were much prettier in the field. And so what we did is we requested the Palisade from our local Syngenta representative, and she gave us details on what they found were the optimal timings and the optimal rates, okay? So she'd worked with this product for, I think, about 10 years in the product development. And so it's labeled for Feeks 4 to 7, but she said it's that Feeks 5 stage where you want to target it, and you want to make sure it's not just Feeks 5, but it's Feeks 5, and then the week after you apply it, you expect active growth, okay? So if it's going to be a cool week, after you want to spray, don't spray. She said it probably will not be effective. You have to make sure that plant's going to grow after the application within a week for it to work. And she said that the 12.5 ounce rate was really the preferred rate. So those are what we did. And you can see here, this is my technician in the field, and we called it his Big Bird outfit. This is what happens when you work at a university and you look for deals on your PPO. You end up, they don't tell you it's bright yellow, they just say it's a spray suit. So he loved wearing that because all the bees and everything else would pester him to death when he was spraying. And so our objectives were really, okay, first of all, the producers wanted to know, is increased nitrogen rates going to increase our yield, right? And if it does increase yield, is Palisade going to be a tool for us to reduce the lodging? And as a scientist, I wanted to know, okay, exactly what is going on in the plant after we apply that Palisade. And so we took a lot of physiological measurements, which I'm glad we did in retrospect, because those are some of the only differences that we found in this study. So I'm kind of spoiling it a little, but. So like I said, we had 3 site years, and in 2014 and 2015. And what we did is I had an undergraduate student. She was very good. We went out, and each of these, we harvested a random stem from each of the rows. So we ended up with 7 stems per plot. And what we did is we measured with calipers the stem diameter. And so what we did is we found that first node near the soil line, and we measured right above that, okay? So for us, that's what we defined as the stem diameter close to the soil level to see if that changed with the Palisade treatment. Then we also looked at peduncle diameters as well, And the peduncle is this last internode that leads up to the head. And so we looked at the length and then also the diameter of that up here above that node. And then we looked at spikelets per head. So we counted the total number of spikelets in that head to try and understand what was going on, because there was a claim, and I don't think I had it on my first slide, but they did say that the heads are bigger after Palisade, which I was very skeptical. I really didn't think that was going to be the case. In 2015, we went ahead and looked at heads per meter squared, and I've converted that into heads per square foot later on. And in 2015, we looked at lodging. You think we're crazy? Why do you think we only looked at it in 2015? So 2014, there was no lodging. 0. Even in our 200-pound of nitrogen rate, we had no lodging. We did have a storm come through during grain fill, and there was a lot of rain and some wind, and we went out, and the plots were starting to lean over. And we thought about taking gradings at that time, but I told my technician, I said, let's just wait till tomorrow. They might be flat to the ground. By the time we got back out 2 days later, because it stormed the whole next day, they stood back up. I don't know how that happened. That was just my luck that year. So we had 0 lodging in 2014. And really, this was about the worst lodging we had in 2015, okay? And I don't know that I would, I mean, it's kind of leaning over, but it's not flat to the ground. We were able to harvest it. But you can see that some of the other cultivars near it stood up just like soldiers. And so that was kind of interesting. Of course, we took plot height right before harvest, at harvest maturity, test weight and yield. And so what we found for the stem diameters down here was that across all 5 nitrogen levels, there was no difference. We didn't find that the stem diameter differed at all between the Palisade and non-treated control, okay? So that differs a little bit from some previous reports. The peduncle diameter didn't change, which I didn't expect it to, but we thought we'd check it anyway. It was exactly the same width. Where we found some differences was the peduncle length, and again, it's the length of this last internode. And we found that with the Palisade treatments, it was almost an inch shorter. I have centimeters here. It was in inches. It was almost an inch shorter. This was very surprising to me. This, I have to admit, I was shocked. I did the statistics on this twice because I didn't believe it the first time. When you have Palisade, there were more spikelets per head than the non-treated. Now, let's get this into perspective. We're talking about 13.4 on average versus 13.1, but it was still on average more spikelets in the Palisade versus the non-treated. So that means there's a potential for a little bit more grain, right? In terms of head per square foot, no differences across all 5 nitrogen levels. But there was an interaction with site, with our site year. And so what we found was that overall, when we averaged the 2 sites, there was no difference. But when we broke them out by site, you can see that in Princeton 2015, for some reason, when we applied Palisade, we had less heads per square foot. And I still don't understand that. I'm not really sure why that happened. Because there weren't any environmental conditions or anything that I thought were strange when we applied the Palisade in 2015. In terms of lodging, again, 2015, actually the Princeton site was the only one that had lodging. And yes, when there's lodging, Palisade does reduce. When you have lodging, Palisade is effective. That's not really all that surprising, is it? And when we look at it by cultivar, really it's the Pioneer 25R32. It's that Pioneer line that actually was more susceptible, more prone to lodging, which is quite surprising because Truman, like I said, is a good couple of inches taller than these other varieties. but it just stands up pretty good. And so I'm not real sure why in our environment 25R32 was more prone to lodging, because actually, you know, in our variety trials, it stands well. It has really good standability ratings. And so we still don't quite understand this. It might have to do with sort of the higher nitrogen rates. It might not be able to handle them as well. In terms of plot height, we did find across all the nitrogen levels that it was reduced by about a little less than an inch when we applied the Palisade. And again, this goes back to the peduncle length, right? That's where the height reduction is coming into play. And so we were really interested in, you know, okay, so yes, averaged across all 5 nitrogen rates, it reduces plot height. But what about at the individual nitrogen rates? Because we did find an interaction in our statistics. And really where we found the reduction was in these low N environments. You can see that, excuse me, that at the 0 and 50, your non-treated were taller than the Palisade. But once you get into normal nitrogen rates that a producer is going to use, there's no height difference in your plots. I found that very interesting. And in terms of plot height, really, what we found is, okay, so if we mine down to each site year, because we also had a site year by Palisade treatment interaction, what we find is that it's these 2 environments, okay? It's going to be Lexington 2015 and then Princeton 2014. That's where we saw the height reduction in our plots. Okay? And so when we looked at our data, these are pretty short heights, aren't they? Are these short for y'all? I mean, 26 inches, 34 inches. Remember, I told you Truman's he's tall. And so actually, the average height of these in a normal year is 37 inches. Okay, so if we look back at our variety trials for 5 quote-unquote normal years, the average of these 3 varieties should be 37 inches. And so what was going on is that in 2014, we had an extremely cold winter. I mean, in Kentucky, we had snow on the ground for a month. We don't ever have that, okay? It was an extremely bitter, cold winter. And actually into the spring, in this environment, we were about 3 weeks late in terms of crop development when you compare it to the calendar. We were 3 weeks late. We had our wheat field day, and our wheat hadn't even headed out yet. We were that far behind. Similarly, for Lexington 2015, they were quite a bit colder than normal as well. Not for us in the western part of the state. In 2015, it wasn't that cold. But really, to me, what this is saying is that when you have some sort of additional stressor, and in this case, it's environmental, it's temperature, that the Palisade seems to thus reduce height, your plot height. I found that very interesting. But when we look at sort of, you know, test weight and yield, there's no differences, okay? Test weight's very important in wheat. There were no differences between the Palisade and non-treated. And then when we averaged the data across all 5 nitrogen levels, the yield was exactly the same, okay? We might have been less than half a bushel, okay? 1.5 bushels, something like that, between the Palisade and non-treated when we averaged it across all 5 nitrogen levels. And so again, we kind of wanted, there was an interaction with site year, and so we kind of broke it down. And it was this Princeton 2015 that had reduced yield. Reduced yield when we used Palisade. And again, I don't quite understand what happened. It's a function of the reduced heads per square foot, right? Remember that I showed you a moment ago? So that's why we have reduced yield, but I don't understand physiologically what was going on to make that happen. And I'm just showing you that data again here. So in terms of when we're averaging Palisade treatment over all 5 environments. If you do not have lodging, it doesn't seem like, this is a no-brainer, right? No lodging, Palisade's not really going to help you much, right? But that doesn't really answer the question that our producers had. The second part of the question was that if you increase your nitrogen levels, will you increase yield? And actually what we found was yes. So overall, discounting the effect of the Palisade treatment, as you increase yield, we significantly increased. As you increase nitrogen, you significantly increase yield. But really, the difference between A and B here is only about 2 or 3 bushels, okay? So statistically, as a scientist, we can say, yes, it increases yield. But I'm not sure that 2 or 3 bushels at $4 wheat is going to really pay, right? So, but that was very interesting. And actually, when we broke it down by cultivar, what we found was that that significant increase past our recommendations of about 120 was really driven by one cultivar. And this is Pembroke 2014. This is actually a variety that our breeder at the University of Kentucky developed. And so it was that variety. So it was really a variety-dependent response. That one variety seemed to drive the significantly increased yield at these higher nitrogen rates. So just to kind of summarize, when we're looking at the data from all 5 nitrogen levels, we didn't find consistent responses or differences in stem diameter, peduncle diameter, test weight, or yield, right? And yield's really the biggie. No difference in yield. Where we did find differences was the number of spikelets per head, and that was a very consistent, strong statistical response. Very surprising, but that's what happened. In the presence of lodging, it does reduce lodging, okay? And it will further reduce plot height when there seems to be another stressor. For us, it was low temperature, or even in the low nitrogen, I'm not sure I showed that, but in the low nitrogen environments, so the 0 and 50, also further reduced plot height with the Palisade treatment. And so some additional stressor, around the time that Palisade is applied will help reduce those heights. But I'm not really sure, any producer that's going to be applying 0 or 50 pounds of nitrogen, right, in their wheat. It's just not going to happen. And so we went ahead and looked at this a different way. And so I looked at it in the 3 upper nitrogen levels, okay? And so 100, 150, and 200. And so in conventionally tilled soils, wheat production, we recommend 100 pounds of nitrogen, okay? In no-till, we recommend 120. And so we have sort of our recommendation and then also the higher nitrogen rates that some of the producers were interested in. And when you look at the peduncle length, again, you see a very similar response. It doesn't matter if you're looking at the upper 3 nitrogen levels or all 5 combined. Peduncle length is reduced, okay? That's a consistent trend. Number of spikelets is increased, okay? And that's kind of where the consistencies stop. Heads per square foot, similar. Lodging, again, is similar at these, if you have lodging. And remember, we don't have lodging a lot in Kentucky. Plot height. You can see, just like we looked at a moment ago, when you're looking at these higher nitrogen levels, plot height is not reduced. It's those lower sort of stressed environments that it is reduced. No difference in yield, and here we're talking about a 1 bushel difference numerically. But if you kind of average in your Palisade treatment, again, you're seeing a response to nitrogen. But in this case, I think it was only about 3 bushels. 3 bushels from the 100 to 200. Only 3 bushels. and then you have double the nitrogen rate. So I'm not sure that really is going to be very economical. And so again, just to summarize the 3 nitrogen levels in our study, it's very similar. The plant growth regulator did not increase stem diameter that we found in our environment, and it didn't affect yield or anything else. In terms of where it did increase was the number of spikelets per head, but that didn't result in any sort of yield differences. So it's interesting as a scientist, but I'm not sure functionally, how interesting it is for a producer, or especially if it doesn't result in any additional yield. Peduncle length and lodging were also reduced, if there's lodging. If there's lodging, that's the big key. And I have to admit, we were very surprised that we got very minimal lodging out of 200 units of nitrogen. I mean, we put in 200 units of nitrogen because we knew it was going to go flat. We just knew it was. And so we just don't understand really what was going on there. So this is just kind of showing what I just talked about. So the only other recent research that I can find published on plant growth regulators has come out of Michigan. Okay? And what they did is they looked at, and they were also looking at Palisade, right, as the new product available in wheat. And they were looking at rates and timings across 2 years. And then in 2014 and 2015, they were looking at it across nitrogen levels as well. And so what did they find? Well, in those first few studies when they were looking at timing, they were looking at Feeks 7 versus Feeks 8. And they were looking at a 12-ounce rate. And so when they're looking at a Feeks 7 or Feeks 8 application, they saw no yield differences across the 2 years. You can see that here. Although the untreated only had 93 bushels per acre, and the Feeks 8 and Feeks 9 had 99 and 100, it wasn't statistically significant in their study. Okay? Similarly, in 2013, there's no differences. In terms of the rate, they found that it didn't matter 10, 12, 14, that in 2012 it did increase yield. In 2013 it did not. Okay, so again, some inconsistencies among the years. It's probably likely due to lodging. So in 2014 and 2015, they just decided they were going to use the 12-ounce rate. And I think they at a Feeks 7 application timing. And in here, in 2014, they found that the PGR application did increase yield. But they found similar results to us. When we're talking about more normal nitrogen levels that a producer is going to use, there's no difference. Okay, it didn't matter if you were at 75 to 135 units. Your yield is similar within these sort of normal nitrogen ranges. They also looked, of course, at peduncle length, just like we did, and just like the Syngenta literature was saying, it does reduce the peduncle length, okay, very consistently. And in their research, every single year, it also reduced plot height, okay, every single year, it significantly reduced plot height. And in terms of lodging, you can see that they had quite a bit more lodging than we did. And so each year, in 2012 and 2013, they had significantly more lodging in the untreated control. And so in Michigan, we know this, they have a little bit more problem, quite a bit more problem with lodging than we do in Kentucky. We just, year in, year out, it's not an annual problem. And so really what they found was that these applications at the Feeks 7 and 8 did not consistently increase grain yield. Yes, 1 year it did, 1 year it didn't, but not consistently. And actually their conclusions were that earlier applications would increase grain yield, okay? That's their conclusions. But I personally, after talking with the Syngenta rep, I think this maybe was a little bit of a late timing in my mind. She said it's critical that you hit, if you're going to use Palisade, you hit it before it joints. She said in Kentucky, that's very important. You want to hit it about the Feeks 5 at a timing right before it's going to be actively growing, because that will give you the most consistent response. Okay? So in my mind, this maybe was a little late. Okay? And of course, hindsight's 20/20. It's easy for me to say this now. They did have an increase in grain yield in 2014, and that was, I think, mostly a function of lodging. Okay? And so when you do have lodging, I'll say this again and again, when you do have lodging, this product works. Okay? You will get increased yield due to decreased lodging. Okay? But in terms of the original intent for why I did my research, pushing nitrogen levels to increase yield and then using Palisade as a tool to reduce lodging, that didn't work out so well. You know, increasing that nitrogen level above our university recommendations did not increase yield. And so that makes me feel good as a university educator, because that means our recommendations are good, right? You know, I think a lot of times our producers think that at the university we're kind of antiquated, right? And we're going with old thinking. But really, behind the scenes, we're doing a lot of research every year to verify those old recommendations are still valid. And in a lot of times, particularly with nitrogen, they're still valid in Kentucky on our nitrogen. And so that's pretty much what I have. And I think I heard the beeper. I'm out of time, aren't I? Oh, I've got plenty of time. I thought I heard a beeper. Go ahead.
I'm curious about test weight and also the date of harvest.
So the test weight, you want me to go back to that slide? So for us, there were no differences. Let's go back and find it. That's yield, plot height. I think the test weight was, it did not differ among any of them. So our test weights were around that 54 to 55 range in these years. And so our harvest dates in Kentucky, so 2014, it was more like June 21st, 22nd. Remember I said we were 3 weeks late due to our really hard winter. In 2014, we were more like the middle of June, which is a pretty normal harvest date for us in Kentucky, if we're not taking it early. And of course, I took this at grain moisture around 13 to 14 is when we pulled it off. We didn't pull it at a high moisture.
Palisade treatments came off at the same time.
They did. Our Palisades came off at the same time. I know there's some literature talking about later harvests, and actually that Michigan paper looked at that. They looked at greenness ratings is what they called it, but really they were looking at delayed harvest maturity. We didn't see that in Kentucky. But you have to remember, in Kentucky, towards that time of the year, we turn off hot and dry really quick, and so everything just turns.
What was the cost for that 12 ounce per acre rate? Do you know what it was per acre?
I did not get estimates. My producers told me very expensive. You know, it was a lot. For some reason, I had, including application, $25 to $30 is what I'm thinking. But I did not ask the rep how much it was. But most of my guys that used it, and there are some guys that still use it, and they were using it quite a bit more before I did this study. They said it was about $30 an acre. And so we can't justify it for $30 an acre in Kentucky. Yes?
I used to raise combine rye. It almost goes flat. You have to scrape the ground to get it off the combine. What do you think are being used for this product in rye or barley?
Yes, yeah. So the question is, would this be useful in rye or barley? So certainly in cereal rye, they use PGRs a lot, and yeah, definitely. Even we do have some guys growing just a few cereal rye for the bourbon industry, and they do routinely use PGRs, and of course it helps it stand up, and it works really well. But most of our guys are switching to the hybrid ryes now. for cereal rye. They stand up better, we don't have this lodging problem, and the yields are very similar. And so I've been working with that the last couple of years, kind of tinkering with it. For our barley, we don't need, kind of like the wheat, our feed barley, malting barley, we don't necessarily need PGRs. They usually stand up pretty good in Kentucky. So, and we do have a little bit of interest in malting barleys as well. At main campus in Lexington, Louisville area in central Kentucky, we have a lot of microbrews that have just opened. And so they really want like a malting barley that comes from Kentucky so they can put Kentucky Proud on it. And usually Kentucky Proud means you get to charge more for your product, right? So there's a big interest. And so I know Laura Lindsay said that they have a big interest in Ohio for malting barleys. There's also a big interest in Kentucky as well. I have to be honest, I'm a little skeptical because of those quality parameters for malting barley. I'm not sure how well those are going to work out for us in Kentucky. We're going to find out. But you know, those are very strict, and sometimes we just don't have the environment to grow the quality they need. What else? I know I went into excruciating detail on this, but you know, for me it was really important to understand exactly, you know, so just saying there's no yield difference, that doesn't tell us what the Palisade did, if it worked. And so in my mind, all my data shows that yes, Palisade has an effect on the wheat crop. But then the other question is, does it pay? And in a production setting, no, it doesn't pay in Kentucky. We don't have enough lodging for it to be a problem. But it is a good tool to have in case we do have lodging. I know I've given this talk several times in Kentucky, and one of it was to a group of CCAs, okay? And so a guy came up to me afterwards and goes, I wanted to scream during your entire presentation. It was just all wrong. And I said, what was all wrong about it? He said, you never once talked about it as a rescue treatment. He said, what about where you accidentally go across the drill twice and you have twice the seeding rate? And what about when the applicator puts twice the nitrogen rate? And I said, I think you need to get better drivers. But you're right. I did not look at it in terms of a rescue treatment because that's not the initial intent. And so this year I actually put out a research trial because that guy was the most vehement, but I've given this talk several times, and every time somebody's asked me about it as a rescue treatment. And so this year I have a study out with double seeding rates, normal seeding rates, and then we're going to do double nitrogen and normal nitrogen applications and see if we can, in Kentucky, use this as a rescue. Yes?
Put on 20 ton of manure.
20 ton of manure. I don't think my farm manager would like that very much. But Josh McGrath, y'all know Josh McGrath, right? He's already doing a big manure study on the back side of the farm, so maybe I'll just partner with him. Yes?
Isn't 200 units double what you generally do?
200 units is double.
Well, see, you already did that study.
I understand. But it didn't lodge, so I did it wrong. You understand? The plots didn't lodge, so I did something wrong. And I totally understand that. The plots did not lodge. You know, and in most situations, in a producer's field, at double the nitrogen rate, they will lodge. So I don't understand if it's a function of the small plots. But it usually isn't, because anytime I do small plot research and I don't want it to lodge, it lodges. And then when you do a research project that you want it to lodge, it won't lodge. And so it's just kind of the way it goes, right?
That would indicate that maybe I should use 150 instead of 100 under those, or not.
Yeah, I mean, yes, these are significantly different. Going from 100 to 150 to 200, they are statistical. It's fairly flat. From here, this was about 85-ish. No, this was about 83, I think. This was 85. This was about 88. So we're talking 2 to 3 bushel increments
I didn't realize
as we moved up. Pretty flat. And like I said, it's mostly a function of that one. This is average across all cultivars. It's mostly a function of that one cultivar. That again, even though it had more of a response, it was still about 3 bushels, for each 50-unit increment. And so yes, statistically you're increasing your yield, but it's not going to pencil out, right? 3-4 bushels. What else?
Did you follow your nitrogen and the soil profile a little bit?
No, we did not follow the nitrogen in the soil profile.
Was it all UAN or ammonium sulfate or double application?
It was all urea that we hand applied. So, because we had the different nitrogen rates, we had to walk it on and hand apply everything. So, in 2014, it was a single application, which I didn't mention because of the compressed growing season. We just had to put it on in one app and be done with it. In 2015, we did split applications. A third of a application rate for 50 units on small plot research is like putting out just a few prills per plot. And so, but we did do a split application to mimic more what our producers do. What else? I appreciate y'all's time. Thank y'all.